There, as you guys already know, there are three types of levers: first class lever, second class lever, and third class levers. And all these levers are actually they are different from one another because of the relative position of the fulcrum, load, and effort. Just to illustrate the three different types of levers, if you look at this diagram, it has got a first class lever, second class lever, and third class lever. So as I said, the differences between these three levers are because of the relative position of the fulcrum, the load, and the effort. In today's track, we'll be concentrating on class 3 levers, where the effort is actually between the load and the fulcrum. So if you look at the practical sheets, it has the apparatus that we required: meter ruler, spring balance, 300 grams weight, and fulcrum, which is a wooden block. As you remember, class 3 lever has got the fulcrum on one end and the load on the other end, and the effort is in the middle. So we're gonna set up this experiment where we have got a meter ruler. So on one of the end, which is the zero point, we'll have the fulcrum, which is the wooden block in this case, and we'll have the other end has got the load of 300 gram mass, which is consists of 1, 2, 3, 4, 5, 6 by 50 grams weight. So we'll have the weight on the 100 centimeter mark. So to avoid the mass from dropping off and off, I'm just gonna clip it with a clip. So that will be on one end, and the other end will have the fulcrum. So if you remember, fulcrum is a point where it doesn't move. So in this experiment, I'll have to press onto the meter ruler, so that I have to press on the meter ruler onto the wooden block so that it doesn't move, and we will just need to measure the effort that required to lift the 300 gram mass at a different point. So the different position of the spring balance from the fulcrum is actually on the table. So we will start with 40 centimeter and then moving slowly towards the fulcrum, which is of the maximum of 100. So, and in this case, the position of the load will stay the same, which is on 100 centimeter mark, and we will just move the effort closer to the weight, to the load, so that we need to see what is the mechanical advantage of having the class 3 levers. Again, the load will be representing by the spring balance. You need to concentrate on the value of Newton, which is on this side of the spring balance. I have got a spring attached in the loop into the meter ruler, so that it enables me to hook it up to the spring balance and then carry the weight off the bench. So we begin with 40 centimeter from the fulcrum. So that will be the position of your effort, which is in this case your spring balance. I'm just gonna hook the spring balance onto the string and holding onto the fulcrum so that it doesn't move. I'm gonna lift the load off the bench, and you need to actually concentrate onto the reading when I try to lift the mass up. So I'm gonna lift it up. So you need to record down the value of your Newton for 40 centimeter from the fulcrum. Again, I'm gonna repeat the same experiment, but in this case, I'm moving the effort to 50 centimeter mark, and I'm trying to lift the weight of of the bench. So please record this value down for 50 centimeter away from the fulcrum. Again, moving away from the fulcrum to 60 centimeter mark. I'm gonna lift the weight up again. Again, moving up to 70 centimeter mark. I'm gonna lift it up. At 80 centimeter mark. Okay. So I'm gonna lift it up. Again, the last one will be at 100 centimeter, which is at the point where the mass is, where the load is. Holding on to the fulcrum, I'm just gonna lift it up. So by now you should have got all the effort needed to lift to raise the 300 gram mass of the bench, and the value that you obtain from your spring balance, you need to record it down on this table. And once you got the effort reading, which is in Newton, you can actually calculate the mechanical advantage, which is the load, which is the load divided by the effort. And in this experiment, they also ask you to actually convert the mass reading of the weight into Newton by multiplying it by 10. So you need to convert this mass into Newton, and then obtain this reading from the experiment that we just did, and then calculate the mechanical advantage of each of the different position of the spring of the load from the fulcrum. So that's about it.